IP version 6 and getting there. Today we are going to do access control lists. So let's get on with access control lists. So share. And that full screen. And let's get to the slideshow from the beginning. There we go. So today we're looking at access control lists. What are access control lists? This is extremely important for you guys. You want to know about this, otherwise I wouldn't bother to do it. And so remember, when you are the administrator for a network, you need to protect your network. You need to protect your machines. Access control list is one of the ways of doing so. So what we're going to look at is what is an ACL or access control list, the purpose, how they work with routers. Then we look at packet filtering, inbound and outbound ACLs, standard and extended ACLs, and ACL placement. So what is an access control list? It is a series of commands that enable a router to filter network traffic based on information. One sec.
Recording in progress.
Based on information found in the packets. So the access control list allows a router to determine what traffic comes in and what traffic goes out, depending on the rules as stated in a ACL. So this filter allows you to permit specific traffic or to stop specific traffic. It also allows a router to forward packets or drop packets, because if it allows packets to enter, it can allow packets to enter a network, or it can block packets from entering. That's what the first line is saying. The second line is saying it allows a router to let packets to leave the network, forward it onto another router to make its way to some destination, or to drop the packet. So this is based on addresses or upper layer protocols, which shows the type of traffic. ACLs provide a powerful way to control traffic into and out of a network. In addition to either permitting or denying traffic, ACLs can be used for selecting types of traffic to be analyzed or processed in other ways. For example, ACLs can be used to classify traffic to enable priority processing. The most important reason to configure ACLs, though, is to provide security for a network. By acting as a filter to allow only packets from trusted sources, or to deny packets from sources that you do not trust from entering your network. You know, many of you know, you're very adventurous, and you go out there and you search and you get stuff. So you can download software from different sources, broken software, jailbreak software, whatever you want to call it. You can download books and documents and movies pirated, right? Those that had copyright infringement and so on. And very often, you know, the old saying, you don't get something for nothing, and free is a four-letter word. Well, the people out there who put out these documents and so on, that they know people like you are interested in getting for free, they lace them with viruses and spyware and adware and all kinds of stuff, so that when you download it and you install it on your devices, then you are exposing all the devices and hosts and machines on your network to these intrusive software and applications and so on. right? Spyware and all kinds of things. So some networks, if you're a network administrator, you have to protect your networks from these things so that you will see that some of these places, when you are trying to download, you are told that this is from an untrusted source. So this is from a place that is known to have bugs and software with malicious intentions, what we call malware. Okay. Some of you, those porn sites that people go on, and we know that Trinidad has a reputation of having the most visits to porn sites per capita. So you have to be careful with all of these things. ACLs perform the following tasks. Excuse me, can't talk very much tonight, eh? It's something going on for this entire semester. Nonetheless, it provides a basic level of security for network access. It screens hosts to permit or deny access to network services, meaning that we allow it into the network or we do not allow you to send packets to certain networks. It filters traffic based on traffic type. I don't know, like I told you, there was a time they blocked those online role-playing games that took up a lot of memory and space on the network and so on, and had people in the labs doing that. They had blocked that. I don't know if they allow it now. I don't know if you can get to download porn or malware and so on, because I haven't really tried to get stuff on campus for a long time. I do everything through my network. And some of these services that you guys might be trying to chase down, I don't worry with. So I don't know what is allowed and what isn't allowed, but these things can be controlled using ACLs. So you can filter traffic based on traffic type. Now remember, filtration works both on traffic coming into the network and traffic leaving the network. We can increase network performance by limiting some network traffic. So the role-playing games and the downloading of movies and so on that take up a lot of bandwidth and puts a burden on the network. If you block these things, then the people who are doing legitimate work for the organization, whether it's student work or employee work and so on, they will have the resources available to them. So they get increased performance. It provides traffic flow control. By default, a router does not have ACLs configured. In other words, you buy a router, you put it on, it's working on the network, it doesn't have to have an ACL. That is something that you, as the network administrator, will have to decide if you ought to have one based on the security needs of your organization or your home, or if you don't need it. But clearly, it is an important thing to have. So you can configure that router. You could build your ACL, your access control list, so that your network is protected. If you put too much security, though, work slows down or might even be hindered. So you have to get that balance. Traffic that enters the router is routed solely based on information within the routing table. That is when you do not use an ACL. It's only what you have on the routing table. However, when an AC is applied to an interface, what do we mean by an interface? A port on the router. So every interface can have its own ACL. The router performs the additional task of evaluating all network packets as they pass through that particular interface to determine if the packet can then be forwarded to a host within your network or to a destination outside of the network, both directions. So here's an example of what is an ACL. So you have a router and you have these hosts on your research and development network, and then you have your host on your human resources network. So this is the company network broken down into two subnets. And what you'll find is packets from a host B on the research and development network is blocked. The router doesn't allow host B to send packets to HR, but it allows host A to send packets to HR. It can be that specific. It could be very general and block packets of all type regardless of source and destination. You choose the type of packet and it can block it based on the kind, depending on, it doesn't matter which machine it's coming from. Or you can block certain machines from doing certain things and other machines can be able to do it. For example, this might be machines that are used by junior employees, and this might be a senior employee or even a supervisor might be able to do this. Okay, so this way you can protect your research and development work from going outside to other subnets or other networks. So here, R2, this is a similar one. What is an ECL? Here we have R2 has a connection to the internet. And we have an ACL on this port that is connected to the internet. Okay, filtering traffic. And we are allowing incoming email, but we deny incoming telnet because telnet can be used to access your routers and do configuring and so on. So we're not allowing that from the internet. So nobody connected to the internet can access our routers using telnet services. Here we have two other routers connected to R2, so R1 and R3. So R1 and R3 get internet access through R2. R1 says, deny video to S1. So this S1 switch cannot get video services. So no devices on S1 will be able to access videos. It deny access to S2 for S1. So S2 cannot get to S1. So R1 here has an ACL on this port connected to this switch, but not one connected here. R3 has one connected here, but S3, this switch, and therefore all devices on switch 3. And ACL for the HR subnet. So this is HR subnet here. Okay. And here we see the address. So by having the address, we can write our ACLs, our access control list, to take into consideration the addresses here. Secondly, this ACL here, on this ACL, we wanted to deny updates, we want to deny FTP, and we want to deny web services. So you can do other things on it, but not these three services.
Sir,
Yes.
for S2, it has no ACL on R1 for S2, right?
Right.
So it's not denied.
No, it doesn't have to, nothing is going to be denied. Everything is going to be permitted, except for what is on the router itself, on the table. There's nothing here specifically denying or permitting services here on this port of R1.
All right.
Just one sec. I think somebody trying to get in. Nope, maybe somebody left. Okay, good question. So the point about this is that it is not by default. You have to specifically put your ACL, right? Write up an ACL and install it on the machine. If you don't do it, it does not have one. Yes, Keldan, go ahead.
ACL is program in a CLI or there's a graphical user interface.
You can do either one. Whatever you can do on the CLI, you can do it on the graphical user interface. It's just two ways of doing the same thing. Okay? There's very little that you cannot do on the GUI that you have to do on the CLI. And we'll see that as we go along in a minute. So packet filtering, sometimes called static packet filtering. Why is it static packet filtering? Because it is written on the ACL and it is done all that way. right? The rules are there. You put the rules there and they work there. The rule doesn't change by the minute. It's static. The only time the rules change is when you replace one ACL with another ACL, or one rule, you can edit your ACL, of course. It controls access to a network by analyzing the incoming and outgoing packets and passing or dropping them based on the given criteria as listed in the ACL, as written out in the ACL, such as the source IP address. You can block packets or a certain kind of service based on what the IP address. So you can say, well, this IP address not allowed to do this, not allowed to do that, not allowed to do the other. Hence the term static. You can also say, well, packets going to so-and-so IP destination address, don't allow that. We're not letting you send nothing to that place. And the protocol carried within the packet. So like you saw earlier, there was on one subnet, we totally block FTP, file transfer protocol. So you can install FTP software on these machines and download movies and books and so on. Yeah? So the source destination, the source address, the destination address, as well as the kind of service identified by the protocol. So those are just 3 examples. There are others. It's not limited to those three. So for the umpteenth time, a router acts as a packet filter when it forwards or denies packets according to the filtering rules. So remember, the main purpose of a router is to decide what is the best path to send a packet on. So how does the router get that best path? Well, it does its calculations and uses its algorithm on the entries in the routing table. And then it will send it out on the particular port for that route. The router receiving that will make the decision for the next step. So that step is made at every router. Remember, one router don't decide the route for the whole destination. Okay? So the router acts as a packet filter. That is an additional service now, and including the main one, which is deciding the best route or the best port to send a packet out from, to send a packet out on, meaning it receives it on one port and it sends it to another port, whether it's to a host or a switch, through a switch thing, or to another router. That's the main purpose. But security is also something, because you have to decide who coming in and who going out. So you can have, when you go into some places, like you go to Napa or Sapa and so on, they have ushers who show you where to go. You ask them, where is this room? Where is that room? How do I get there? And they can show you the route, how to get in. And then they will also tell you, well, you can't go there now, and you can't do this, and you can't do that. You know, there's no smoking, there's no eating, there's no this. So they also act like a bit of security, you know. So if somebody coming with food and thing, they'll have to give the guy a warning. So packet filtering can work at different layers of the OSI model or at the internet layer of the TCP/IP. So here, packet filtering works on the OSI model. It works at layer 3 and layer 4, the transport and the network layer. With the TCP/IP, it works at the internet layer. The router can filter packets based on the source port and the destination port of the TCP or UDP segment. Remember, TCP is one kind of packet, UDP is another kind of packet. And remember, segment is for a kind of packet, one, you know, a part that you get when you break down large messages into smaller ones. So you have inbound and outbound ACLs. So ACLs are configured to apply to inbound traffic or to apply to outbound traffic. So inbound is what is coming into the router, and outbound is what is leaving the router. An inbound ACL filters packets coming into a specific interface and before they are routed to the outbound interface. So when it comes in, the router inspects the packets, right, on the You see, the ACL is applied to a specific interface, not all the interfaces. So when the packet comes in, the router examines this packet to see if there are any rules that would prevent it from being accepted, right? So it checks the ACL and it looks for the packet, the information on the packet to determine whether to send it forward or to drop it, right? ACLs do not act on packets that originate from the router itself. Now remember, the router will have packets. When will the router send out packets? Anybody want to tell me? Can the router create its own packets to send out? Does a router do that? Anybody?
I would believe so. If, for example, if you're doing a broadcast address, if the router want to do a broadcast address.
Right. So there are certain things that the router will do for what, and we call that overhead traffic, right? The router does things. Remember, we said the router send out updates periodically, and we did that last week or the week before. We talk about updates. Remember, the router does create packets to respond to DHCP requests. Remember, the router also does ARP and RIP and all them things. All those things originate from the router itself. So the ACLs do not humbug that kind of work from being done, right? So if the router is creating its own packets, it's going to send them how they want. Another router receiving these packets may decide to block them or to process them, okay, and send them forward based on its ACL there. An outbound ACL filters packets after being routed, regardless of the inbound interface. So when the packets come in, regardless of where it come in, the router will decide based on the ACL whether to let packets go out, depending on what the rules are, okay? Incoming packets are processed before they are routed to the outbound interface. An inbound ACL is efficient because it saves the overhead of routing lookups if the packet is discarded. So that's why we process it before. Before we look out for the best route for it, we have to see first, hey, we sending this packet forward or not? And only if we decide we're sending it forward, then we would look up route. So there's no point of doing work on it if we know we're not going to send it. Hence, it is more efficient. If the packet is permitted by the tests, it is then processed for routing. Inbound ACLs are best used to filter packets when the network attached to an inbound interface is the only source of the packets needed to be examined. So you see here, right? This one here has stuff coming. This is the only source packets coming from, except from here. So this router, we could consider this one an inbound interface. So we could put ACLs here. Similarly, this one is the internet here, the only one coming in. Incoming packets for outbound ACLs, incoming packets are routed to the outbound interface, and then they are processed through the outbound ACL. So the packet coming in is examined against the incoming ACL, the ACL on that port for incoming traffic. And then depending on where you're sending it now, it has to be processed by the outbound interface to determine if it will be allowed to go out that port. So yes, it comes in into this one, but are we going to let it go out that one? It depends. Outbound ACLs are best used when the same filter will be applied to packets coming from multiple inbound interfaces before exiting the same outbound interface. So it's a little bit easier and more manageable when we have it like that. Okay. The two types of ACLs are standard and extended. So we're going to look at standard ACLs and extended ACLs. Just excuse me for 1 second, please. All right, never mind. Right. So standard ACLs, we're going to look at standard one first, your normal basic ones. The standard ACLs can be used to permit or deny packets based on source IP address. The destination of the packets and the ports involved are not evaluated. We're not interested in that. We're looking at the source where it's coming from. So we can block packets depending on who's sending them, right? And you do that at home sometimes, and you look at your phone ringing and your partner calling you. Well, I ain't talking to him now, because I can't go nowhere to live. I have too much homework to do. Do you ever see that? Or I ain't talking to him now, he want the answer for the assignment. So you act as your own filter, but as manual. So when you put those things, you have those things kind of set on WhatsApp and your phone calls, you block certain people, you have notifications, you allow notifications, you block notifications, and so on. That's kind of like an ACL filtering incoming traffic. Then you have extended ACLs. These filter packets based on several attributes. So the standard one is just the source we're looking at. The extended one, we look at other things like the protocol, the type of service the packet is providing, the source IP address, right? The source IP address, like I tell you, including the standards, it could be places that have known to have software or files, whether it's software, books, videos, movies, whatever, that have malware in them of different kind. Then we have some based on the destination IP addresses. We're not sending out anything to those places. Okay. Source TCP or UDP ports, right? Depending on the kind of service. Again, the ports are, in some cases, the ports are standard for some services. Remember port 67 and 68, port 80, right? I'm sure you know some of these. Destination TCP or UDP ports, and they are optional protocol type information for finer control. You can have more detailed control. These are, when you talk about source IP address, that's a kind of gross control. We want nothing from them people, right? Going down to this kind of information is we don't want this kind of files and whatnot, but we will allow so and so, right? Where to place ACLs. Every ACL should be placed where it has the greatest impact on network efficiency. So it depends on where you're going to plug it, over here, here, incoming, right, on the port. The proper placement of an ACL can make the network operate more efficiently. An ACL can be placed to reduce unnecessary traffic. Here, on this one, we have standard ACLs are usually placed near the destination. Extended ACLs are usually placed near the source. Source meaning for inbound and destination for outbound to devices and servers and so on. A standard ACL can only filter traffic based on a source address. We said that earlier, right? The standard ACLs filter traffic based on source IP address. The basic rule for placement of a standard ACL is to place the ACL as close as possible to the destination network. So in other words, you're only doing the filtering down there. This allows the traffic to reach all other networks except the network where the packets will be filtered. So here we are seeing, this one says, block all traffic, right, from 192.168.10.0 to so and so, right? So you're blocking from a range of IP addresses. So that will be a standard ACL. The next one on this side, this one filters traffic from here to all destinations reachable by R3. So here we have, this is 192.168.30.0. And this one is from .31. So we have a filter here allowing only certain traffic. It filters traffic from that only. All these now get to go in. Placing a standard ACL at the source of the traffic will effectively prevent that traffic from reaching any other network through the interface where the ACL is applied. Extended ACL placement, though, like a standard ACL, an extended ACL can filter traffic based on the source address as well as on destination address, protocol, and port number. This allows network administrators more flexibility in the type of traffic that can be filtered and where to place the ACL. The basic rule for placing an extended ACL is to place it as close to the source as possible. This prevents unwanted traffic from being sent across multiple networks only to be denied when it reaches its destination. You see, if you're allowing it to go through all the places except the destination, then you are creating network traffic for nothing. But if you put it as close as possible to the source, all right, and you filter it there, then these packets not coming in to the network to plug up your system, only to be dropped later on. There's no point in doing all this work, right?
So, sir,
Yeah,
the
go ahead,
ACL,
sir.
the ACL does process everything before every rule, basically. Like
Once the
standard only,
router, like,
sorry.
go ahead.
So the standard only processes the source and the extended processes all of them.
Right, so
And
the
that's the traffic.
standard ACL only filters traffic based on the source address. It only looks at where stuff is coming from.
Yeah,
The
my question
extended
is,
ACL, the extended ACL also looks at, apart from the source address, it looks at the kind of service, the destination address, as well as the port numbers. Remember, we talked about certain services like UDP uses port 67 and 68, and TCP uses others, and HTTP uses port 8080, and so on. So it would look at the port as well to block those things. So the difference between standard ACL and extended ACL is the extended ACL can filter traffic on a bunch of different rules, whereas the standard ACL can only filter traffic on source
source.
IP address.
Right.
Yeah. But we put in, the point we're making at this point is we put in this extended ACL where as close as possible to the source. So the earlier we filter, the better, because then we're not allowing unwanted traffic onto the network, because they'll just block it down the road anyway. So you may as well block it right here. Network administrators can only place ACLs on devices that they control. So remember, we talked about autonomous system and we talked about border or gateway devices. So I could only place ACLs on devices coming into my network. I can't put it on the ISP router. They have their stuff, right? If they allow me to configure their router, I might be able to do some stuff on them, but they might not allow me to put ACLs on their side, okay? And if I'm connecting to, if I run a business, I'm running a manufacturing business, excuse me, and I have suppliers from different places, right? So I'm running a supermarket and I am receiving stuff from, let's say, AS Bryden. But they allow me to connect to their network. I can't go and put ACLs on Bryden's network. I'll have to put it on my network, on my side, to control stuff on my network. I can't control on other people's network. Yeah? So you have to decide that. You can't put a security guard on the road by the junction where you live and say, well, you deciding who could come in and out of that road because other people live on the road too, right? If you have a road coming off and it's only you controlling that piece of land and what have you, you could put somebody by the entrance or in front of your gate and say, well, you could control who come in and leave your property, but you can't control the neighbor one. Okay? Same thing here for this. That's all. Placement of the ACL, and therefore the type of ACL used, may also depend on the extent of the network administrator's control. It depends on what level of control you have. It could also depend on the bandwidth of the networks involved and the ease of configuration. Some of these things might take a little bit more work, right? You have to kind of know what you're doing. Otherwise, you could mess up the work being done on your network. You mightn't intend to do this or that, but a badly configured ACL can prevent real work from getting done. So you have to know how it is you're doing it and be prepared to make these changes. Access lists should be used on firewall routers. You understand firewall routers, right? They create a barrier between outside and inside, so you don't want to let any malware in, which are often positioned between your internal network and an external network such as the internet. That's like your gateway routers. You can also use access lists on a router position between two parts of your network. So you have a subnetwork to control traffic entering or exiting a specific part of your internal network. Remember earlier we saw where we had HR on one side and research and development on the other side? Those are two parts of our network. And we could put ACLs to control the traffic going through there. Good? So we're not finished. So here, we're going to take a look at this one. So this slide is, right, access control list, like what we were looking at just now, right? It's the same source, Cisco. And the same, we saw this one earlier, the purpose of the ACL and so on. And here, you will see the communication between two devices, okay? And the exchange of packets. So with the blue packets, the blue arrows go in one way, that's from this device, and the orange come in the other way. So you can see how a conversation takes place with sending data and what have you. You familiar with this, I don't have to go through this with you, but it's a basic representation. Okay, and we have the filtering. And this one says, right, now we have more detail. So now that we understand ACLs, we can go through and get a little bit of detail in it. So our standard ACL, we said they filter packets based on the source IP only. Here's an example. This is access list 10. And it says permit this IP address and this 000.255. What does this mean? Right? Anybody can tell me? What you see in here, this is a mask, not a subnet mask, right? But it works a similar way. Remember, 255 is what? 8 ones. And? Agreed? Now, so when a packet comes in, right, we're going to take the address of the packet that comes in, and you see with these 3 zeros here, it means that if the packet gives you this, right, when a packet comes in with whatever address it is, right, we will do a thing with this here. And once it has 192.168.30, it don't matter. This tells us is a kind of wildcard thing. It doesn't matter what values are in the fourth field. Once the first 3 fields is this, block it. Right? So all values in this would be blocked. Okay? This one says a similar thing, right? This one says, sorry, I just told you the wrong thing. This says permit.
Yes,
It
I
will
was gonna
allow
ask,
Right. It will allow packets from with these three thing here. Once it has these three thing here match, it doesn't matter what it have here. On this last field, everything will be allowed because it says permit here, not block. Right? Over here, this says permit TCP packets. This one is based on service. Right? So this one is a standard ACL because it's based on the IP address only. This one, we come in with the kind of service. We allow TCP from here, right? On this port. Okay? We will get some more examples in a little bit. Extended ACLs filter packets on several attributes. So we saw that earlier. Okay? Wildcard masks and subnet masks differ in the way they match binary ones and zeros. Wildcard masks use the following rules to match binary ones and zeros. A wildcard match bit 0 match the corresponding bit value in the address. Wildcard mask bit 1 ignores the corresponding bit value in the address. So if you watch here, right, we said that because of these three zeros, we will match these three and allow it. Because of this 255, it doesn't matter what value it have in the last field, we will still allow it. Okay? So from all values in the last field, we will accept it because we ignoring those. The zeros tell us where we need to have our match, and the same goes here. So wildcard mask examples and match ranges, right? Here, remember what we have now. This tells us we're restricting between here and here. The base IP address is this, right? Why? This here, these 255 tell us that we're going to accept all of these. So the wildcard mask is 0.15.255.255, so that we will restrict only this and not all. So let's see how this works, right? This here, remember this is 128, this is 64, this is 32, and this is 16, right? By the wildcard having 15 here, it means it has 4 ones here. 1 and 2, 3, and 4, 7, and 8 is 15. And the 255s mean all ones. So it means that in that base address, if you look at the base address here, this, right? This is 172. And up to here, this is 16. Okay? So once we have this, it means we're going to keep it regardless of what goes on down there. It don't matter, we're going to ignore this part. We're only trying to match here. We want the exact match up here. Okay, so there's the minimum with that value and the maximum. So anything between here to here in this range, we're going to allow it. Or restrict, as the case may be. Right? If it says restrict, well, then we'll have to block it, regardless of what values we have down here. So we're not going to take on these with the ones. Ignore those. Question: what IP address does this combination isolate? If this is the base IP address and this is here, what does it isolate? Well, we are seeing the 3 zeros here, right? For these 3 fields, we'll accept this. And the 254, right, is 1, 2, 3, 4, 5, 6, 7, and that is a 0. So we're going to ignore all the values that has here, right? And this one is the one we isolated. Okay? That would be dot 0, 0, 0, 0, 0, 0, 0, 1. See? So we ignore all the parts of the ones. Right, guys? So although this is 37 here, it's only the one part we're gonna think. Anything that has a 1 in it, well, that's a problem at the end. So isolates all the odd numbers in the subnet, because once you end in with a 1, you're going to get an odd number. See, as we said, once it has a 1, we're going to have that issue. So there's all the odd numbers. Wildcard mask of this keeps all bits. Keyword is host, right? And when you have all this, eliminates all bits, and we have any. So this here, now when we have this, we're going for a particular host with the wildcard, and with this, we're ignoring all the bits, the entire address. So the ones tell you where to ignore, and the zeros tell you where your restriction taken place. So look at this one here. This says, this first one, access list one permit this. What are we doing? Right? Permit any. This one here, permit this. If this means that it is a particular one. Only this particular host we're looking for. Yeah? So this says all the ones in the address we're going to ignore. So that means we're going to allow any host to come in. This one says we will allow only a particular host. Guidelines for creating ACLs, the 3 Ps, right? 1 ACL per protocol. Don't confuse them with too much thing. To control traffic flow on an interface, an ACL must be defined for each protocol enabled on the interface. 1 ACL per direction, right? 1 access control list for each direction. That's the incoming and the outgoing. 2 different directions on the same port. Okay? Because you have a port, you have a router, you have a port here, right? And you have ports here and whatnot, right? So this router will have traffic coming into that on this, and it will have traffic outgoing on the port. So one is inbound and what is outbound. So you have to have an ACL for each one. And you also have 1 ACL per interface, right? So for each one, you have there's an interface, there's an interface, there's an interface. ACLs control traffic for an interface. For example, gigabit Ethernet 00. It depends on which one. This will be like a serial port or something with that speed. Every ACL should be placed where it has the greatest impact on efficiency. We talked about that earlier. The basics rules are, excuse me, extended ACLs, locate extended ACLs as close as possible to the source of the traffic to be filtered. And standard ACLs, because standard ACLs do not specify destination addresses, place them as close to the destination as possible because you don't want to block traffic for other destinations, okay? Divide the S's. What's the S's? The standard ACLs. Entering criteria statements. So these would be like your criteria statements. There's your filter in here. So this says deny any traffic from this network. Internal logic. Rule 1, you cannot deny something you have already permitted. So if you have entry on an ACL up here that says permit something, you cannot have something down here that says deny it. Because what happens is how the ACL works is that when it gets a packet, the router is going to look at the ACL, it's going to read it from top go down, right? And if it sees something that says permitted, it's going to permit it. If it sees something denied, it's going to block it. So you can't deny something you've already permitted. So lower down, when you come and see block there, when you already permit up there, too late. And vice versa. You cannot permit something you've already denied because it drop it long time. We don't hold on to see, let me see if something else can block it. If nothing is permitted, nothing will pass, right? The best ACL in the world does nothing if it is not applied. You have to apply it. So here you can deny a specific host by having a specific address, right? Here, alphanumeric name string must be unique and cannot begin with a number if you have a name to represent that. It activates a named IP ACL on a list. So you have a list with a name and whether it's standard or extended, you know, permit, deny, comment. And here you can edit your ACL. So you have to understand these rules. You can go through them. They're very straightforward and simple. You know what to access. Once you understand wildcard masks, then you will be able to read them. What is it you're permitting? What is it you're denying? And so on. So you can read these when you get more time to follow up on them. So this one is one called traffic use. Permit TCPs, permit UDPs, permit IP. This says any here, this one would be source and destination. So between any and port ET, right? So this is like a thing, your line number kind of thing. And this is your rule. So you allow TCP traffic from any to any and so on. And here you have other stuff. So those will be things that you could read and follow up and think at an extended part. And of course, we talked about IP version 6. You have IP version 4 ACLs, IP version 6 ACLs. So you could do those readings. Yes. And then here, this is an actual portion of the book. Thing, it's routers. There's access control list in routers. It has the same information, what it is you do, how it works, so you can read those things, right? So each line on a router, on a access list, a router uses an ACL to deny or permit traffic to or from a network it protects. So it goes through, right? If it comes through on the first line, you pass the first line. Remember, we were just talking about that. If it passed the first line, then we allow it, it goes through, right? If the first line doesn't allow it, or the first line doesn't say anything about it, we go on to the second test and the third one and so on. Anytime we meet something to deny it, we get rid of it. Anything that we says allow, we send it through. So once this says yes, and this allow it, this one can't come and block it because it done going through already, right? So this is like the top of the list, and this is like the bottom of the list. So I would have done it vertically to demonstrate that here. So it's the same thing we do right through, and it allows you to read the stuff. And then we talk about intrusion detection devices. IDS is an intrusion detection systems, and IPS is intrusion protection system. So they monitor stuff on your network. Okay, so your IDS, right, is on the side there. This is detects, it monitors and observes what is going on to detect packets that may be intrusive. The IPS stands between the firewall and your network so that it will prevent packets from coming through. This one don't say what could come in and what could go out, but it can tell you when. It can detect and intercept traffic to protect a corporate network. So the IPS will protect. So the IDS detects and the IPS will detect and prevent. So this serves as a filter here. This one doesn't filter, it just monitors and flags when something looks fishy. So HIDS is a host-based intrusion detection system. That it means that it runs on a single computer to alert about attacks to that one host. So that's like you have a system and IDS on your computer. That is a host-based one. And NIDS, a network-based one, is when you have it on a device placed on the network to monitor all traffic to protect all hosts. Okay, so you might have something on your system blocking on yours, but other devices on the network, they don't have the same protection. So this one allows you to protect your computer based on your rules. And this one allows you to protect the entire network on general rules. Okay, so they talk here about a demilitarized zone. That's like here, it can detect many types of suspicious traffic patterns, including those typical of denial service, DOS, or smooth attacks, for example. Okay, so you could do some more reading and understand these things. Some of these like firewalls and so on, I think you would have done those in CNET 1001. Yes, class, tell me. Nobody an answering. All they want to tell me what all they do on CNET or not do on CNET.
To be honest, I can't really remember if you do firewalls in CNET.
All they are feeling bad to tell me that. So remember from day one, I told you, if it's just to review your slides, just read it and go through it and bring it up so that you could understand these things. Because when I'm doing this, we're building on what you have done before. Okay, so that's basically it for ACLs, access control lists. And what I can show you is, let's see here. So this is when people last year, right? This would have been last year, September. So this here, if you look at this is a familiar thing. It's a VLSM. You're given a network and you have to design a subnet scheme using VLSM for these requirements. So you will notice here that you've been given how much you want here and here and here, right? How many would you want for this network, for this one? How many addresses will you want here on the one? Anybody?
2.
2. So if you want 2 addresses on the one, 2 host addresses, what does that represent?
/TT subnet.
Who?
Not
Say
a
that-
serial, they're not serial connections, sir?
It's a serial connection. So what do these two addresses represent? It represents an address for here, this port, an address for this port. Okay? How many addresses will you need on this one in total?
4.
You will need 4. The 2 ports, right? And you will also need what? A network address and a broadcast address, right? So you will need at least 2 bits minimum for this network. So you can work out how much you need for here and here and here. But you'll remember your WAN needs 2 bits because you need 2 addresses, okay? Plus the broadcast address and the network address. So you'll go to this and fill out these. Yours is going to be very simple, but your network will be a little bit different. And then you have questions on networking. This one was asked for the TCP/IP network architecture model, outlining the services provided and the protocols used in each layer. So you're supposed to know this, and you're supposed to know the one for OSI. There's a CNET 1001 question, and people still get it wrong because why? To be honest, I can't really remember what we do in CNET 1001. Root summarization, and we do that? So you ready for that? What's another word for root summarization? Anybody?
There's root aggregation.
Right.
Supernetting.
And supernetting. Excellent. So we could summarize, and well, this one says summarize these 4 roots, but clearly the idiot who said the paper meant 3. So something like that wouldn't cause you trouble if you had to do it, right? It's just 3. And you see what it says here? Show all relevant working. Don't just write down an answer. You're getting marks for your working. You have to show me how you get it. When you are working in an organization and you have to do something, you don't just come and tell them, well, boss, XYZ. They will want to know, how did you get there, right? What did you use to arrive at that? Because they'll want to hear your logic. So this is like working for an organization, and I tell you, the payment you get is in marks, not in dollars. Was the subnet mask for this? Again, show how you get it. A host on a network has this IP address, while the default gateway has this. Are the host and gateway both on the same subnet? So if you're trying to figure out how to do this, well, you have some problems. And here it is now. What impact will the answer here, yes or no, have to do with this? Now, again, explain your answer with all relevant working. If you put yes or no, you're open, right? You can't get 4 marks for yes or no. Seriously. Okay? Some people will just, they don't know, so they hit a guess, and there's a 50-50 chance that they will get it. Because if it's either yes or no, then there's a 1 in 2 chance you will get it right. Okay, and if you get it right, well, you're getting 4 marks. Over here now is you have to say this, the applied part. What impact will that yes or no have on the host's ability to communicate with other devices on the same subnet or other devices on other networks? If the host and the gateway are on different networks, then obviously you cannot communicate with other networks, right? You may be able to communicate with the same network, but you won't be able to communicate outside. And if they are on the same network, both of them, that means that they are configured properly. They will be able to communicate, well, everywhere, inside or outside. Now, also to here, if you will see here the subnet mask is the same on both of them, right? If the subnet mask were different, you could automatically say, well, no, they're not on the same subnet. But if it is the same, then you have to go and think about it. This one, you have 2 hosts, not a gateway, but 2 hosts. Are they on the same subnet or are they on different subnets? And you have to, again, answer here. Oh, it doesn't say anything. It might have asked about their communication. It might have had another part to that. All right. What's the differences between a switch and a router? This is CNET 1 question again. Right? This is embarrassing. All they put in this question here was a layer 3 switch. In what way is a layer 3 switch different from a router? So you have to give some little detailed answer to get them little 2 stupid marks. You have to answer properly to get that. Switches may or may not perform the functions of routers. At what layer of the USI model do switches operate if they do not perform router functions? That's so easy, it's embarrassing. So here's the question we was really looking for. An ACL is used by a router to improve security on a network subnetwork. What is an ACL? How does the router use the ACL to determine what it must do with the packet? So you have to go through the process. Well, it receives the packet and it checks the first entry and the second entry and the third entry until it goes through all the entries. At any time it meets one that says permit, it would let it go through. If it sees one that causes it to deny, it will deny, and it will go through the whole entire list to determine what must be done. And if there's nothing there to allow it, it will have to get dropped. What does the following ACL entry tell the router to do? See? ACL to permit this to that, so we'd have you do some reading and practice. What does this following ACL entry tell a router to do? Do some reading on that. Link state protocols, example OSPF, are generally regarded as superior to distance vector protocols, example RIP. Compare RIP with OSPF. Well, you have oodles of information doing that, right? I do have to come and give you those answers. And distance vector routers periodically send out updates. Describe these updates. That is also on your information. Yeah? Algorithms with shorter convergence times are better. What is convergence? We do all that. And they're easy. That's why you're getting 2, 3 marks and thing. And it adds up, eh? Them 2, 3 adds up to plenty. And these 16 and 20 and 30 and whatnot adds up to 100. Okay? So this morning we were talking about things, well, not in class. This is another conversation with other people about philosophy of life and so on, and how little things add up to plenty. So when you were in preschool, you would have learned a song, little drops of water and little grains of sand makes a mighty ocean and a beauteous land. So don't underestimate these little 2 marks and 1 marks here, because that could go to A or F. And name and describe 6 metrics commonly used by routers to compare and select the best routes among multiple options. So you'll name 6 metrics, you will describe them and how they are used. And you know them, right? I don't have to tell you. Authorized users with laptops are able to get access on the school's Wi-Fi network automatically once on the campus. IP addresses are leased to them for a given period of time. Explain the 4 basic steps of the leasing process. Describe the lease renewal process. Right? That's 4 marks and 4 marks. 8 marks for what? DHCP and DORA end. Yeah? So you can't just come and write DORA here and get 4 marks, eh? You have to go through the whole thing. You have to talk here about the what? The 50% and the 80%, and if it's not renewed, it restart, and the timer and whatnot and thing. You have to put in that whole information. Both IPv6 and IPv4 will coexist in the foreseeable future. Explain and describe 2 popular methods of interoperation of these 2 protocols. So we're talking about what? Tunneling, and where's the next one? I can't remember. Somebody told me about it last week, but I can't remember.
Dual stack.
Dual stack, right? So you can't just mention that to get 2 marks. You might get half if you just mention it. I don't mean half of the 2, I mean half. 1 half. And of course, now your exam not going to have these same questions coming back, obviously. But your paper is going to look just like this. right? And how much did I have? This one had, how much you see? 7 questions and it add up to 100. I think this year you have 5 questions, but it will have more parts. So instead of 10 and 10, it'll have 20 and 20 and whatnot and whatnot. Okay, I'm gonna put up this year one. That would have been good, eh? So I gave you tips last week on what coming. The final exam, did I? You know, out of 30 something people in
No,
the
sir.
class, nobody an
You give us
answering.
topics. You give us topics, sir.
I gave you topics.
Yeah.
Thank you. There are 36 people present. See how long I had to wait? So there will be 19 pages and 5 questions. And well, it had the marks 24, 10, 26, 25, 15. That adds up to 140, 66, 90, 100. Yeah. So you will be able to use basic calculators, non-programmable calculators. Please show your working. Okay.
So that file you was just showing us on Canvas, or no?
Say that again.
If the file you was showing us just now, the last file you showed us, is it on Canvas?
Which file? The question paper, you mean?
Yeah, the question paper.
No, I didn't put up question paper on I don't think it's on Canvas. But
Okay.
and I tell you, you all have how you call it? They put up all the things, the library put up all the past papers and things. So it should be
sir.
easier to get past papers.
But some
Okay,
old
sir.
ones.
Yeah. So I think this morning I asked people if they got past papers for what should I call it? For
Object oriented.
OBPR past papers, and they put up their hand and they said yes. And yeah. So you should be able to get access to it. If you real check for some reason and by some mysterious phenomena, it's not available, or you can reach out and let me know. Yeah?
Yes, sir.
So one of the things that I wanted to do with you guys, you know, in case all you feel that I'm not prepared and I don't know what I'm doing, I don't know what you say behind my back, eh? And don't worry, I hold you guys in very high esteem. So keep packet tracer folder. Right. So let me see if I can share this with you. There's a bunch of packet tracer activities that we had. Remember, I told you I wanted to do some labs with you. So some of these down here would have been simpler ones that, like what you would have done in CNET 1001. And this one, lab 6, is a basic router setup. So let's see where it shows up. Basic router setup. Right. So here is, this is Packet Tracer. Remember, I told you to download and install Packet Tracer. And it says the aim of this lab is to test your ability to perform a basic router setup. The idea here wasn't to test you on nothing, was to give you the practice to go through it. But as you notice, right, every class we had, I don't think I wasted time in class. We had to cover material. So we really didn't have to do the time. We didn't really have the time to do this kind of demonstration. I wanted to do it with you. It says configure correctly the laptop terminal software and the router to the console and name this and name that and how to do it. And then we had, let's see, this here would have been the activity. I think you're all familiar with what packet trace activity looks like. And you will see it is the same thing here as was on the here. It's the exact same thing, right? So you could go into the laptop and configure and pass the rules and things shown. And this here, they want you to try to use the CLI, the command line interface. Now, are there anybody in this class doing the network and telecom option of the computer engineering degree? Or everybody doing the software engineering option? What are you majoring in?
I think I'm major in network.
In network,
Network,
Yeah.
yeah.
Yeah, so
right?
same here.
Which means that you all have to do network architecture 2 as a mandatory course, right?
I believe so.
Right. So in that course, you will cover this. And generally, as far as I remember, it's Mr. Rajnath. It's not Rajnath, Mitra something. Mitra from Sandotech. He usually teaches that course. And before him was Mr. Wilbur Roberts. So I'm not sure what's going to happen. So you're going to cover this kind of thing. But just these are easy to get. You can go and get your answers for it. So you can, those of you who are interested in this, right? Don't just say that we didn't get to do it in class. You can go in your spare time. You are doing this degree, this program, because you like tech. You like technology, you like IT, right? And if this is something you like, then you don't mind spending time with it. Okay, I did this degree because I liked it. I told you that I had the option of doing a math degree and getting a promotion on my job where I was, and I did not. Instead, I chose to do an IT degree because I liked it. Okay, and since then, I've always been learning new stuff. I've done a million courses on different things since then, both teaching myself or attending classes and thing of one level or the other. Because remember, after bachelor's is master's, after master's is PhD, and then there's these other professional certifications, right? Because I also did CCNE and a number of other things. And then this morning too, I told you that just a few weeks ago in August, I did the ISO 27001 training. So you'll always be learning, and not everything you're going to class to do. So that is why you train in something you like, so that you will always enjoy learning new stuff in it, and you will also enjoy doing that as a job. You won't hate it. If you hated studying so far in this program, well, then it means that you had a difficult choice to make, right? And you chose something that you're not really happy with, or you chose because somebody tell you, but as you feel to go in, you can make money there. But if you don't like it, there's a problem. You can still salvage and do a decent career on it, depending on which side you want to operate on. So you can choose that. But the point I'm trying to get on is that you can go ahead and you can learn these things. Because check this out, right? So here, you should be able to see this file, right? And you can see that I have this one connector router to a LAN, and here's connector router to a LAN answers. Configure initial router settings. Here's configure initial router settings answers. Create a simple network. Troubleshoot gate default gateway issues. Troubleshoot default gateway issues answers the same. Packet activity, the PKA or packet trace activity, is the same name of the activity with the answers. So you could go on the internet and you could look for packet tracer activities because it's not really given out to people who are not Cisco students, if you're not a student of Cisco Networking Academy. But these things are available, so you can still go and use it and learn from it. So when you open the packet tracer activity, like this one, here's the packet tracer lab set up for you halfway, right? What we would have liked to do, just to let you know, is that we would have liked you to come into the lab at Point Lisa, so John Deere or wherever, and give you these devices, 2 routers and 4 switches and 4 computers, and say set up that network and configure everything. You see all the greens? These greens means that they are working. The network is working. So we can come in here and we can go into the desktop and we can start applications. You know, we can do IP configuration. Okay. We can do physical configuration. We can put in devices. The green, sorry. Right, this little green light here is on. That means the device is on. I can press the power button and turn it off. Okay. I can take out devices and plug in modules and so on, but I could only do that if the device is off. Okay. Right. The config desktop, if I click here on config, right, on config, it tells me it's locked, right? It's locked by authors designed for this activity because they don't want you doing the GUI stuff, right? Then you can have the desktop. These are, you see DHCP, we're using static and so on. So they have different conditions and what have you. So sometimes now you can get the different applications will be running on the different PCs for you to do your thing. And it's just like if you're doing it on a machine, it's a simulated environment. And here's the thing about the simulated environment, okay? Yes, we like to work on actual hardware, but the thing is, in the simulators, everything always working. When you connect everything, it always working. You don't have to worry, well, I wonder if the problem is the cable. Or if I didn't plug it in good. Did the switch die? Is the computer? If I have to wait for all these devices to turn on to do this. And then think about it now, how long it will take to set up this before we go to get the actual work done. And then if you have to work in groups, let's say groups of 4 people, then you have about 12 groups in this class, right? So if I have 12 groups in the class, that means I have to get 24 routers, 48 switches, 48 computers. That is physically impossible. So the simulators, the actual hardware, nice to work on, but the simulators actually make it easier to do. Okay, so when you do this, you have the activities that you have to do in it. Okay, and then you could also get the answers. And when you look at the answers, you can go and it tells you what to do. When you go through it, what do you do? Let me share it with you. So the red font color indicates text that appears in the instructor copy only and what have you. So then it gives you the answers on what you have to do. Okay. It gives you the commands and the instructions you put in and what you get out and what have you. So you could go and you can find this and you can answer the question. See, there's the answers. How many serial interfaces are there on R1 and R2? Each router has 2 serial interfaces and so on. They are the answers. So you can get this and you could go and do some work. This, remember this morning I was telling you about being lifelong learners. And this is how we demonstrate for you to be lifelong learners. You have endless resources all over the place. You have the textbooks, you have the activities, you have the internet, right? It's like almost without end. The only thing it requires now is for you to go and get that work to do it. And the question is, how would you do it? You can do it with your friends. You can get together and say, let's do some of this. And here's the interesting thing. You don't have to meet by one another house. You don't have to meet on campus. You could go and do this just so you could create a Zoom meeting for yourself. Granted, you wouldn't have 3 hours. You might get 45 minutes, but that might be enough to do a small activity. And you can do these things together online, and you can work with each other and build each other and grow together. And you might be surprised that you might end up working for the same company. And even if you work for different companies, you work in somewhere and you get in trouble, but you're afraid to let somebody, well, no, I don't know how to do this, I don't know how to do that. Well, you could do your usual research, and then you could call up somebody who you've worked with and say, hey, remember we was talking about so and so? Well, here the problem I'm having. What you would do in such a situation, and you can get help. Okay, so you can develop these lifelong learning, good practices of collaboration and what have you, that could take you in good stead forever. There are people I studied with in year one. There are people I studied with in masters. There are people I worked with side by side, and I could still call them today and get help, or they will call me and get help, vice versa, and so on. Right? And it's a good thing for me because it keeps me on my toes. It always keeps me up to date with stuff. So based on that, that is the kind of things that I am hoping that I passed. And we have spent the last 13 weeks together, and I am hoping that you enjoyed it, and I'm hoping that you pass your exams with really good grades. I hope that you were able to learn some stuff from me. Granted, I am never able to do everything that I wanted to do. We don't have that kind of time. But you have skills, you have knowledge now that you will be able to do these things. Let's take a minute and get a roll, please, people. So let's see where we are. Aaron Lewis, are you here? Antonio? No. Azaria, yes. Shrees, yes. Shrees Solomon, no. Daniela, I think I saw Daniela.
Yes, sir.
Right. Darius is here, I saw Darius. Gabriel Charles. That's what? No. Gabriel Samru is here. Isaiah Matthews, Jared Bino. Right. Jonathan. Josh. Josiah. Kiran. Keldon. Carla. Carla is here. That was Karen Pierre. Carla is here. Chris, yes, me. Majid, I noticed you reached late again, eh? Don't feel I didn't notice. Liam. Oh, sorry, we have Liam here. Liam is not here. Micah is here. Michael, Michael, Mohini. Nafisa is here. Neelan, Nicholas, Nevedita, Rahim, Shivanan. Next, Shivanan. Shivanan Jawa here is not here. Zachary Joseph. Surik is here. Zion. Kevin. Yes. Omari. Yes. Isa.
Yes, sir.
Right, I know. Right. Joseph Jagrup, yes. Mark Samaru, yes. Ethan Clark. I could swear I let Ethan Clark in. Was that my imagination?
He was here, sir.
You sure?
Yeah,
Okay. Jamil Boyce. I don't remember seeing Jamil.
yeah, yes, sir.
Jamil Boyce, you are here?
Yeah.
I ain't seen your name.
So is that right there? The last one?
No, I seen it on the list. I mean on the participants. Oh, wait. Yeah. Boyce. Jamil Boyce. My bad. Yes, you are here. Right next to Jared Bino and from far your name looking the same. So yes, my bad. Sorry, you are here. Good. So we have a few people absent. 1, 2, 3, 4, 5, 6. So any information you will share, right? It's okay, Majid. I'm just teasing you and harassing you. I do that. It's nothing no big deal. Don't take it on. So before we go any further, are there any questions, comments, fears? Because all you seen until all the exam. Talk to me, tell me what's going on with you guys. You all okay? Everybody submitted their assignments?
I think we're right, sir.
Yes, sir.
Double check. Let me double check, sir.
All right. Well, you don't want to double check this second. But if you want and you go through it, you can update and re-upload anytime until I go and download. When I go and download, today is what? Maybe Monday. Monday next week I might download everything and mark your quiz and start marking your quiz and so on. So if you do any updates and fixing, you can review and re-upload. But after that, don't worry because I might not see it. And of course, I wouldn't have time to call people and say, hey, I ain't see no assignment for you. I ain't see no quiz for you. What did you do it? Did you not do it? So make sure and think that. So last call, anybody has any questions, any comments, any suggestions, any issues? If there is none, I will let you go now and wish you good luck in the exam. I really, really hope that you had a good class with me. And well, I will probably see you in January. No, yeah, I might see some people in January with DSAL 3001 if you've already done algorithm and data structures. So I hope you wouldn't have a problem when you semi in front here again and back. So go out here again, right? So thank you so much for your patience and giving me the opportunity to teach you. I hope you were able to learn something from me and that you enjoyed my little quarreling and insult something. Don't take it personally. You guys know I was kidding and teasing. Thanks so much, Darius, for your feedback. I appreciate it. So take care, everybody. And please use your time well and study and good luck in your final exams. I really want everybody to pass.
Thank you,
Thank you,
sir.
sir.
Good.
Yes,
Keep
sir, me
well.
too.
Yes,
Bye.
sir. Good night.
Good night.
All right, sir.
Take care.